Hey everyone, and welcome to the AI Research Roundup. I'm your host Alex, where we chat about interesting AI research. Okay, so today we're looking at a paper titled Multi-SWE-bench, a multilingual benchmark for issue resolving. It came out April 3rd, 2025. The main idea here is that current benchmarks for fixing code issues mostly focus on Python. So this paper introduces a new benchmark covering 7 languages, like Java, TypeScript, Go, and Rust. So yeah, expanding beyond Python is the key goal here, and they really put effort into making this benchmark solid. It includes 1,632 high-quality test cases across those 7 languages we mentioned. They actually started with almost 2,500 candidates and used this detailed 5-step process to narrow it down, including manual checks by dozens of expert annotators to ensure everything was accurate, using similar quality standards to the original SWE-bench. They've also launched an open-source community, Multi-SWE-bench, to build up reinforcement learning datasets for this task too. Alright, so let's look at some results. Figure 1 here shows the resolved rate, basically how often the models successfully fix the issues. On the left, that radar chart shows overall performance across languages. You can see Python really stands out, much higher than Java, TypeScript, and the others. And on the right, the bar charts break it down by difficulty. Easy, medium, hard. Performance clearly drops off as tasks get harder. Okay, and building on that point about quality, Figure 2 here actually shows us that 5-phase process they use to construct the benchmark. You can see how they start with selecting repositories, then crawl the relevant pull requests, set up Docker environments, filter based on test results, and finally do that manual verification we talked about. Okay, going further. Figure 4 gives us a different view, breaking things down by specific models and methods like GPT-4o or MopenHands. Instead of just the final resolved rate we saw earlier, this shows the actual flow. You can see how many issues are successfully located first, and then how many of those actually get resolved. It really highlights where the process might be breaking down for different languages. Alright, so building on that breakdown by model and language. Figure 13 here focuses specifically on how the size of the code fix, measured in tokens, affects the resolved rate. You can clearly see across pretty much all languages and methods, performance drops off significantly as the required fix gets longer. Yeah, and building on that point about fix complexity, Figure 14 here looks at how many files needed changing for the fix. Well, it's a pretty similar story to fix length. The more files involved, the lower the resolved rate tends to be, pretty much across the board for these different languages and methods. Okay, so looking at those complexity factors, it's pretty clear resolving real-world coding issues isn't simple, and things like fix length and file count really impact success. What this Multi-SWE-bench paper provides is a crucial multilingual benchmark, letting us properly evaluate how AI models actually cope with these challenges across different languages. It's really valuable work for moving towards AI agents that can genuinely assist developers with practical tasks. Well, that wraps it up for this episode of the AI Research Roundup. Thanks for listening. I'm your host, Alex.